Alright, Mike, this is how it works. Here's battery group 1. Alright? This is how 1 used to work. Battery 1 would go on, and battery 2 would be off. Then it would go battery 1 off, battery 2 on. The whole time, the load would be pulsing when we're driving the circuit. This is your PWM output. Now here, right now, the old school way, we would just drive these two batteries. Right here, this is how they would charge. So when the resonance cap up here would receive a back EMF, it would come through here, back through the circuit, and into, when this one is unloaded, now we're driving a load with battery 2, battery 1 is getting the back EMF right to the positive rail, okay, because of this MOSFET. When battery 1 was driving or loaded, the opposite, this would shut it off, and then this MOSFET would allow power from the back EMF to go to battery 2 positive. Alright? This MOSFET is just power control. It turns the power on the drive circuit. These two MOSFETs here, which were also tied with battery 1 and battery 2, would drive the pulse routine for the resonance cap here, the resonance tank circuit. So as these would pulse, it would control the pulse routine for the coil and the resonance tank circuit. And then the back EMF would be collected, and then on every single pulse that was generated would be allowed to pass through either one or the other of these two FETs. The problem we had is we're not able to get enough energy stored in the cap to overcome the battery's natural resistance. So what I have to do is, instead of having these switch together, all 4 of these FETs, and then all 4 of these FETs for battery groups 1 and 2, I need to do just 3. So this one would come on, and then this one would come on at the same time but turn off roughly an adjustable duty cycle amount later. So anywhere from 50% up to 95% duty cycle adjustability in this MOSFET to allow pulses to build up in this capacitor, which I would say, okay, it's been a 95% duty cycle, bang. This would drop its load into battery 2, pulse charge, and then shut off just prior to the battery switching back over to the other side, to the other battery, and the other MOSFET would take the charge. But its on and off time has to be adjustable with the duty cycle, so I can collect the pulses from the pulse train into the coil. The pulse train into the coil has to be a constant. So as these switch back and forth, they produce, oh doggone it, a pulse into the resonance cap. So that's constantly seeing the same pulse routine, which is double what each battery is doing, because each battery causes a pulse to go to the resonance cap. Resonance cap stores the back EMF. Back EMF goes to the MOSFETs here, which have to be broken out from the routine I currently had, where battery group, battery group. Well, now we want to take, instead of 4 FETs per battery group, we want 3 FETs per battery group, eliminating these 2 and putting these 2 on their own control, or I can control the duty cycle. Hopefully that helps. Over here you have the pulse train. Battery groups 1, so there'd be 3 MOSFETs driven by, or 3 pins driven by this signal, all tied to this signal. On, off, battery group 2, on, off, equal and opposite, 50-50 duty cycle. Charge rail, on, when battery 1 is on, this charge MOSFET opens and charges to now battery group 2, which is off. It's on for roughly an adjustable duty cycle, half of it. Okay, right now, just for demonstration, 50% to 95%. Then it turns off. This allows the cap, this dead space right here, allows the capacitor to charge. When it comes up, this next battery, 1 goes dead, unloaded, 2 goes loaded. This one turns on and allows the power that was charging to be passed through the MOSFET to the now unloaded battery 1. It's taking the charge. So forth and so on. As they alternate, these alternate. Controllable duty cycle in between. Alright? down here is the continuous pulse train, which is generated from the batteries just constantly pulsing. Bang, 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 bang. It generates, I know it's not to scale, but you see it constantly sees a steady pulse train. That pulse train is what is dumped into these two control capacitors, control the charge and discharge of the capacitor. Alright? This final, there's one more. Do I have it here? I don't know if I have it here or not. Here it is. And all this one is the PWM, or control for the load. Now if you remember, the load is right here. That's the load. So the load just goes on and off, and drives the motor load. Alright, see, the load is right there. So when this turns on, and so this just is dependent on the output driving a load. That's these other two pins. But that's basically it in a nutshell. I just need to break out these two MOSFETs, control them separately, but at the same time that the motor's driving, or that the circuit is driving the battery circuits. You know, does that make sense? I'll send you, of course, this file so you can closely look at it. Hopefully this helps. Let me know what's going on. But basically, I just need to get these two pins, which are the discharge capacitor, the discharge MOSFETs, to have an adjustable duty cycle, and that they are on and off inverse to one another. Okay, they both can't be on at the same time. See, and their on time coincides with the off time of the batteries that they're going to. But that's it in a nutshell. Hopefully that helps. Let me know. Thanks.